Hi, today we're going to be looking at the alternating series test for convergence and divergence. Now, to determine if a series is alternating, it's one of the easiest ones to recognize. You can just really look at this -1. All the alternating series will have something -1 to some power. And I could have like -1 to the n plus 1. I could have -1 to the n. The only things you want to be careful are the non-alternating ones, and sometimes the AP will try to throw one of these at you, something like -1 to the 2n, or something like -1 to the 2n plus 1. These are non-alternating. Matter of fact, the first one gives us, this is going to give us all positives numbers because you're squaring a negative. And this one's going to be all odd powers here, so that's going to be always going to be negative. What you want to make sure is that your series is alternating, your sequence is alternating, like 1 minus 1/2 plus 1/3 minus 1/4. And if it's alternating, then you can use a new rule. Now, the alternating series test comes from our nth term test. Now, the nth term said we did not want the limit as n goes to infinity to equal 0. That's the nth term. Then it meant it diverged. Now, normally, if the limit does equal 0, it doesn't tell us much about the convergence or divergence. That's why when nth term fails, we had all those other tests. However, in an alternating series, we want that limit to equal 0. Now, there's another rule that says that the terms have to decrease in magnitude as well. So for an alternating series, we're going to want the limit to equal 0 this time, unlike in an nth term. So here's what the rule says to do. If a series is alternating, the series will converge if the following two conditions are satisfied. One, that the limit as our sequence goes to 0. So in other words, basically our sequence is decreasing in size. And also that the next term is going to always be less than the previous term. In other words, again, to show that it's decreasing. Sorry, this isn't sequence is decreasing. This says the sequence is approaching 0. Which again, I guess, is just getting smaller and smaller. There's a difference because the signs can work. So we want that sequence there to approach 0. Now be very careful. Like the nth term test, we're not saying that the limit does not equal 0. It diverges by alternating series. No, no, no. If the limit does not equal 0, we say that it diverges still by the nth term test. So be careful. We cannot diverge by alternating series. So let's take a look at a few examples. This is very easy to do. Up on our first one here, we want to know if this converges or diverges. First off, I recognize, yes, this is an alternating series. I'm going to write that down. We'll abbreviate it later on. So the first thing we say is that this is alternating, and my rule said to take the limit. I take the limit as n goes to infinity, and I can include the negative part here, or I don't have to. It doesn't really matter. I just want to see if it equals 0, and it doesn't matter if it alternates or not. So to make it simpler, we're going to find the limit without the alternating part. 2n minus 1. Now you may notice this becomes 1/2. Now that does not equal 0. Now for alternating series, we want this to equal 0. Does not equal 0, so this does not converge by alternating series. It does, however, diverge. Now, why does it diverge? By the nth term test. See, the nth term test already has a claim to the limit as n goes to infinity equaling 0. Does not equal 0, sorry. So we cannot diverge by alternating series. We can only diverge in this case by the nth term test. Like so. So if we try the next one, again, this is alternating. So I'm going to take the limit. The limit as n goes to infinity. Ignore the alternating part, that's this part. I get n over the natural log of 2n. Well, if I do this, I get infinity over infinity, and we have to use L'Hopital's, the greatest cheater in all of the land. Right? We've talked about him before. Now, to take the limit as n goes to infinity, we're going to use L'Hopital's. We take the derivative of the top, which is 1. Now the derivative of the bottom just becomes 2 over 2n. Simplifying it using a little bit of algebra, we get the limit as n goes to infinity of n, which is infinity, which is quite the opposite of what 0 is. So again, this series will diverge because we want it to equal 0. So we say that the series diverges by the nth term test. And there's our answer right there. We're done with that one. Alright, now let's take a look at one that will converge. These are a little bit harder, okay? So again, this one is alternating because at negative 1 to the n. So I'm going to check it. Take the limit as n goes to infinity. I take the nth term test, and I get 0 this time, which is what I want. But that's only part of it. We have to make sure that the sequence is decreasing. So we need to make sure that the sequence decreases over time. So we have to check the next term with the previous term. Now that's easy enough to do. If I want to find the nth plus 1 term, where there's an n, I plug in an n plus 1. So I would go 1 over n plus 1. And here's my original, 1 over n. Well, is 1 over n plus 1 less than 1 over n? Yeah. That tells me it's decreasing, that my values are getting smaller as my terms increase. My terms are getting smaller, so it's decreasing. So therefore, we can now say this series converges by what we call the alternating series test. Now, be very careful. What tends to happen is people tend to think, now, okay, if we're using the nth term test non-alternating, then it can converge by alternating. Be careful, don't get the two mixed up. Okay? Now, if you have any questions, please come see me or text me or whatever, or message me. On part 2, I'm going to go ahead and do what's called absolute and conditional convergence. And it's something that's special with alternating series. So I hope to see you then. Bye.